Probabilities by tree diagram. Guided practice 1. Consider two archers firing simultaneously at a target. Lee has a probability 3/4 of hitting a target, and Yuka has a probability 4/5. For A, draw a tree diagram and label all the information above. When we draw a tree diagram, normally we get started from a dot. We have two events for this situation. First one is Lee. Lee will fire at a target. The probability will be 3/4 of hitting a target. Therefore, there are two results for Lee. One is hitting the target. The other is missing the target. I use H stand for hitting, M stand for missing. Now let's check the probability. For Lee, the probability of hitting a target, that's 3/4. So 3/4. Missing will be 1 minus 3/4. You get 1/4. Remember, this is properties for tree diagram. From one point, you have a lot of branches. For example, you have A, B, C. Then A plus B plus C equals to 1. This is a very important probability for tree diagram. IB exam, they test a lot. You can check here. 3/4 add 1/4, you got 1. After they fired at a target, then Yuka will fire at the target. There are two results for Yuka. One is hitting. The other is missing. Hitting here, missing here. We'll write down the probability for Yuka too. Yuka has a probability 4/5, so here's 4/5. Use the property of a tree diagram, we can get the 1/5 here. This is the 4/5 and a 1/5. After you completing this tree diagram, you will get the outcome. From very beginning, go to this line, go to the H, then go to H. Outcome is HH. Probability will be 3/4 times 4/5. Then we have, here's H, then go to this is M, HM, which means Lee hit the target while Yuka missed the target. Probability will be 3/4 times 1/5. Then we can look at this line, M and H. Probability will be 1/4 times 4/5. Then we have, this is M. Probability will be 1/4 times 1/5. There is another property for tree diagram. For all this probability, you add together equals 1. Let's go to B. Find the probability that at least one of them hit the target. Check the outcome. As long as there is H, which means will be the answer. We have 2H for the outcome. This one count. We have 1H here, count. 1H here, count. Therefore, I just need to add all this probability together. That will be our answer. So we got the 3/4 times 4/5 plus 3 over 4 times 1 over 5 plus 1 over 4 times 4 over 5. Add together, you will get 19 over 20. Let's go to C. Find the probability that only one of them meets that target. Basically, I'm looking for only one M in the outcome. This one count. This one count. In other words, I add these two probability. That will be your answer. So we have 3 over 4 times 1 over 5 plus 1 over 4 times 4 over 5. You will get the 7 over 20. Let's go to tree diagram 2. Two drawers contain a number of colored balls as indicated in the diagram below. These two drawers. Two experiments are carried out. First experiment. A drawer is first chosen at random, and then a ball is drawn from that drawer. A. Draw and label fully a tree diagram to show all the possible outcomes of this experiment. First of all, you have to choose a drawer from two drawers. So we have two choices. We see this is a drawer 1 and here's drawer 2. After you chose a drawer, then you will draw a ball from it. Look at the drawer 1. We have two colored balls, black and white. So we go, here's black and white. For drawer 2, still we have two colored balls, black and white. Now check the probabilities. Together we have two drawers. If you pick up one from two drawers, which means we have 1/2 as a probability. For drawer 1, altogether we have 5 balls, 2 black, so we get the 2 over 5. We can use the property of a tree diagram. 1 minus 2 over 5, that would be 3 over 5. Look at the draw 2. Altogether 3 balls. So we have 2 over 3 and 1 over 3. That's it for A. For B, what's the probability that a white ball is drawn? Check where you can find the white balls. This is a white ball. This is a white ball. From very beginning, this point, how I go to white ball, this line goes to white ball. Then we have another line. This line go to white ball. Therefore, the probability for a white ball is drawn, you will get 1/2 times 3 over 5 plus 1/2 times 1 over 3. Your answer will be 7 over 15. Second experiment, the ball drawn in the first experiment is not replaced, which means this is a dependent event. Your denominator will reduce by 1. A second ball is then drawn from the same drawer. What's the probability that both balls are white? So we keep finishing this tree diagram. For the second experiment, you still have two choices after you draw the first ball. So we get black and a white ball again. Black, white. Black and white. Black, then white. Let's check the probability. Since this is a dependent event, you always go to the same color first. After you draw the black ball, this is a dependent event. Remember how you get the probability of getting the same color, black. Your denominator minus 1 go to 4. Your numerator minus 1, you will get the 1 over 4. If you already got the 1 over 4, the white ball will be 3 over 4 because 1 over 4 plus 3 over 4 equals 1. Same here, from white we go to white. Therefore, you will get the 2 over 4. Then here's 2 over 4. Don't reduce for the tree diagram because the denominator shows the total ball you need to choose from. This is black, so we go to black. Therefore, you get the 1 over 2. This will be 1 over 2. White, we go to white. 0 over 2, that's 0. Therefore, this is 1. What's the probability both balls are white? So we choose 2 white. White, white here. White, white. How we go to this white from very beginning? You will see from here, then you go here, go here. This is one line. Another line is from here, go here, then go here. If it's the same line, you have to do multiplication. Therefore, you will have 1/2 times 3 over 5, then times 2 over 4. 1/2 times 3 over 5 times 2 over 4, then adding 1/2, 1 over 3, then times 0. 1/2 times 1 over 3 times 0. You will get 3 over 20. Let's go to tree diagram 3. When Andy plays tennis, 65% of his first serves go into the correct area of the court. If the first serve goes into the correct area, his chance of winning the point is 90%. If his first serve doesn't go to the correct area, Andy is allowed another chance of this 80% go into the correct area. If the second serve goes into the correct area, his chance of winning the point is 60%. If neither serve goes into the correct area, Andy loses the point. Number 1, complete the tree diagram below. Use the property of tree diagram. We can get this will be 0.9. Since here is only one line, therefore it will be 1. For number 2, find the probability that Andy loses the point. We'll check on the tree diagram where you can find the lose the point. It's here, here, and here. Then from very beginning, how you go to these 3 lose, you have go this line. this line and go this line. You have 3 lines go to lose. Therefore, you will multiply by the probability on the same line. Then you add all these 3 lines together will be your answer. For the first line, you have 0.65 times 0.1. For the second line, you have 0.35 times 0.8 times 0.4. For the third line, you have 0.35 times 0.2 times 1. Then you add all these 3 together. You will get 0.65 times 0.1 plus 0.35 times 0.8 times 0.4 plus 0.35 times 0.2 times 1. Then we put into calculator, you will get 0.247. Now let's go to number 3. Find the probability that Andy win. Check when. This one and this one. So from very beginning, how you go to these 2 wins, you have one line like this. Then you have the other line like this. If it's on the same line, you do the multiplication. So you have 0.65 times 0.9 for this win. We have 0.35 times 0.8 times 0.6. So we add these 2 together. You will get 0.65 times 0.9 plus 0.35 times 0.8 times 0.6. You will get 0.753.